Go live. All right, guys. So let's do this. I have a USB-C to HDMI cable coming in soon, so I can stream the iPad over. So today, as a stopover or a stopgap method, I'll be using the Windows version of Shaper 3D to show you guys. Um, you know how I kind of do this. So what we're going to be doing is on this screen here. Um, what's going to be shown is, let me see if I can turn down. I've got to reduce the resolution that these are streaming at, uh, so that so the stream goes through a little bit quicker. But we're going to be working on this Samyang 12 millimeter f2. The mount is for Micro Four Thirds, and I would like to use it on, um, let's just say the Sony E mount, right? So I'm going to show you guys how to do that. Micro Four Thirds mount. First thing that I usually do when I start something like this is I'll get a physical mount that I can look at, that I can take measurements off of. Alright, so the orientation of this is red dot to white dot, so that's going to be your standard position so that you get it aligned correctly. And with a lot of these Samyang Rokinon lenses, uh, they typically come with these shims, and these shims are here to help reach critical focus. Um, they typically come on most cameras to meet that critical focus, or essentially to make sure that you can reach infinity. So this is the mount that they use for the Micro Four Thirds, and what we're going to do is we're basically going to um, we're going to reverse engineer this part, and that's just a fancy way of me trying to make it sound like I'm actually doing something. What I'm going to do is I'm going to take measurements, recreate it in CAD, replace this section with a E-mount, and then print it. But everything that I do here is typically what I'll do when starting a new design. Most of the mounts I have on file already, so I don't actually have to make those anymore. Um, they've been tuned and fine-tuned over a couple of years to make sure that they do fit. So first off, we want to make sure that we get a few measurements, and it's usually overall diameter on this, which is looking like it's 55, right? And you can move it around to make sure that you're hitting the right places. Like that's too little. There you go. So 55 millimeters is what we're looking at. So let's jump in and open up a new design here. Since we're on the Windows version of this, I have it streaming onto my iPad, which I know is kind of stupid. I do need to get that, what do you call it, that HDMI cable. So this is what this here you can change your unit of measurement. You keep it on millimeters, and for most design things, I'll keep it on millimeters. The only time I'll move to inches is if um, if I have specifications specifically for standard uh, imperial units, right? So anything, if I have an SAE bolt, move over to inches. Um, if there is a specific item that I'm trying to recreate and I don't have the metric measurement on it, go into inches. But one thing that you should always, I guess one thing that I've noticed is that if you are in inches, if you export the STL and open it in Cura, what happens is you get an incorrect sizing. So Cura will bring in that model either much smaller or much bigger than it actually should be. So before you export your STL, if you're in inches, foot, or anything else, make sure to change it back to millimeters. And then I typically like to lock my grid at 1 millimeter because that gives me enough resolution to get into the tiny details of what I'm trying to do. So let's make that circle. So from the center, and on Windows, you can type in the diameter here. This this symbol is showing that it's measuring diameter and not radius. When Shaperd first came out, it did measure. It did base its measurements off of radius. So I mean, it's easier now because I can just type in the radius instead of having to worry about, um, you know, I can type in the diameter without having to worry about dividing by 2 to get the correct diameter. So now that we have that inputted into the CAD program, what we're going to do next is we're going to measure the distance from the center of the hole here to the edge of that. I find having a screw in there makes it much easier because you can gauge visually the center of that screw versus gauging the center of an open hole. So we're going to hold that there like that, and then we're going to use the other side there. And so right now I'm getting about 3.25 to 3.2. I think it's 3.25. I'm sorry, I'm gonna mute my phone real quick. Go do not disturb. Okay, so it's inset about, I know that says 3.2. If I move it too much, it's going to jump off of where I actually need it to be. So what I want to do now over here is offset the edge, and we're going to click that, and we're going to say we're going to offset that negative 2.35 or 3.25, right? So we've got that interior circle that crosses through every point here, right? So what we can do next is if we're going to get a rough estimate as to where our, I guess this would be the orientation point, right? This is directly up if we're holding the camera, right? So this aligns with the camera center. So since we have 2 points that we can measure from, it's pretty easy to determine where our center is. So what you can do is you can scribe a line. I'm trying to find my straight edge here. You can scribe a line from the center outwards, and it's very faint, but it's right there. And then you can go from the center of that dot there, and we're going to find find that distance. We'll round it to 18.5. What that is I forget my geometry. A tangent, a ray, a tangent. I don't know, one of those. But what we're going to do is we're going to say that this is our center line. So this is where the red dot would be, right? So that's the red dot, matches up to that. And then we're going to take another line, bring it out here, and what I want to do is click on this guy, and we want to make that 18.5. First, we've got to constrain a few points here. I want to constrain these points and the length here because if we don't, you'll see that it moves like it did when we did the initial change. So let's do 18.5 again. And there we go. So this is where, if we were to draw a line and then trim it, is where this mounting hole is. So why we did that is that we can get the appropriate I'm trying to measure there we go. So we're trying to get the degrees or the angle that it is off from center, right? So this mounting hole is about 40 degrees off from our point of orientation there. So we're going to write that number somewhere. Let me pull up, I'm going to write on a piece of paper. That's what I'm going to do. This is literally how I do it. Whatever space that I have, I'll write it on. So 39.311 degrees is what we need. And what we're going to do with that is we can go here to the polygons and we're going to pull triangle. So my assumption is that these three holes are spaced evenly across, so it's essentially an equilateral triangle, right? So we've got about 20 or 42, roughly the same distance from each other. So we can, with that information, use a polygon triangle, which would give us an equilateral triangle. We can find that all of our mounting holes will be in the same general area. Well, all of our mounting holes will be equidistant from center and equidistant from each other. We're going to measure the interior of that hole, which I don't think we can, except here. So 175. We're going to measure that bolt. 1.6. So 175 is probably a good number to go with. We're going to change that radius to 1.75. 1.75. And then we're going to measure the head of the screw or the bolt. And that's probably safe to say 2.5 is what we'd need for that countersink. So I'm going to zoom in here. And let's bring the circle up. And that's 2.5. So let's enter that. And then what we can do from here, instead of having to do this again, what we can do is we can select these two guys here, and we can go exit sketch and move and rotate. We can bring this to the center of that and say I want a copy every 120 degrees because that is 360 divided by 3. So we get another copy, 120, and well, didn't work. Let me just do it here again. -120. Puts it there. Alright, 120. Brings it over there. And we're copied. Good. So we've got that. Now all we need to do is delete a lot of miscellaneous sketches. And I need that gone, this gone. Delete that, that. What I'm trying to do is just clean this up so when we go to extrude, it's a little easier to manage. And I'm going to trim these guys here. That. This one out. Go back up here. Trim this guy. This guy. This guy. And keep that line up there. Alright. So, now that we have that, that's great, right? What we need to do next is we need to get the initial we need the diameter of the interior part of the Sony emote that we'll be using. So for that, I'm going to use this Metabones adapter. I find that the Metabones is fine if you have it's the thing I have on hand, right? If you have a emote on hand, that's great. If you don't, anything will really do. So you can see that there is a ledge here which insets into the camera lens itself, and we're going to get a rough measurement on that, which looks to be 46.76. I'm going to round that down to 46.75. So if we zoom back out, position to give us center, let's go ahead and sketch. And we said 46.75. Now you might be asking yourself, it's conflicting with the mounting holes. Yes, it is conflicting with the mounting holes, but that's entirely fine. Because, I mean, technically we don't need the entire ridge there. What we need is just enough so it fits in that we can cut out on the mount itself. And then the next thing I want to do is I want to measure the interior of this interior baffle that they have on the back of the lens. And I'm getting somewhere around 27.5, 27.4. I'm going to err on the bigger side and say that's 27.5 because I don't want it to hit this part of the rear element. So let's go ahead and input, said 27.5. In all honesty, we probably make that 28, but that's fine. And then we have this guy and this guy. So we're going to start building things out now that we have general measurements of everything that we need. So let's exit sketching. And I want to extrude the baffle, or the lower mount part of the mount here. So this mount here, when you design for 3D printing, you have to think about how things are printed too. So if you have something like this, where you were to print this, where this side would be face down on the printing surface, you get a mesh here from the supports that you're printing, and it will throw off your overall design. So I find it always easier if I'm gonna be designing something, I want to make sure that either it's in two pieces so that I have flat surfaces and I can maintain that degree of accuracy. If not, if I don't do two pieces, what I'll normally do is if I look at this and if I see that I don't really need this extension here to go into the lens, I'll just cut that off, right? So in the design itself, I'm probably not going to include this extrusion from uh, the base here. So we're going to measure from this base uh, to the back here. Um, we're going to have to do two measurements, right? We're going to measure from here to here, and then from here to here, so that we can subtract that little lip. So we get 9.35, 9.35, and then we use the back end of the caliper to measure the distance from that. And you want to make sure you have 2 points touching so that you don't get a measurement that's off. Got 1.75. Let's see if we can get anything else. 1.5. 1.4. 1.4. I think it's 1.4. I believe it's 1.4. Yeah. 1.45 maybe. No, we're getting 1.41. 1.42. 1.4. That's what I'm going to use, 1.4. I'm going to do one last measurement on this guy here, make sure that I am still within that 9.35, 9.35, 9.3, 36, 35. We're going to do 3.5, or 0.35. So, what I want to do next is go 935 minus 14, 5, 13, 9, 8, 7. So, you're looking at 7.95 millimeters for the back of this base to the bottom of that. And then let's jump over to flange focal distance. And since this is a Micro Four Thirds mount, that flange distance is Micro Four Thirds. Micro Four Thirds. 19.25. And we want to move over to Sony E, which is 18. What I'm going to do is 19.25 minus 18 is 25. So I have to add 1.25 to this guy here to give me the actual base or thickness of the mount. So 0, 1, 10, 12, 1, 8, 9. I'm smart, guys. I'm smart. I know how to math. So we got 9.2 for the thickness, right? So let's see, 9.25, 18. So we can add that. So what I want to do is I'm going to extrude this, right? So we're going to click on this guy. Let's see here. This guy, no, not this guy. No, yes, that guy, that guy. We're going to do the most that we can so that oh, come on. You know what? forgot to press shift, so then it didn't select what I wanted it to, guys. It's so bothersome. Alright, almost there. And what we're going to do is extrude, and I want to extrude downward because right now it thinks that I want to go up, so we go negative 9.2, and that right there is our base. Well, it doesn't look like much, it's just a circle. That's what I always say, things are just circles. What did I say this was? 27.5. You know what, we'll just make 28, make it easier for us. We're going to extrude that down, actually. Let's take that, extrude it out. This is our basic mount. Right now, this is the basic mount structure. I can probably make these pockets here. And here. Extrude those all the way down. And then I probably want to do the same here, right? We want to make sure that so that we can countersink the hole or the machine screws into the mount, so it doesn't affect the lens mount. And we're gonna pocket that maybe 0.5, and just to be safe, what I'm going to do, where are my layers? There they are. Let's turn that off. To be safe, I'm going to make this 0.3 to give us enough room to make sure the screw can get countersunk in there. And if we take a measurement off of this, 0.5, alright, probably 0.7, you know what, probably do 0.1. Since we might experience some difficulty, so negative 0.5 should get us that 1 millimeter inset. Alright, so now that we have that, let's turn our sketch plane back on and turn that off. Now we want to extrude this beveled or this extruded part here, and then also the main part of the flange. So you need to take a measurement on this guy, and then make a depth measurement on this extruded part here. So getting the calipers on there, we're looking at around 43.53, which on this I'm probably gonna round it down to 43.5 so that it will fit. Let's get the sketch going. 43.5. One second here. Okay. So now that we have that, right, what I'd like to do is I'd like to extrude that bump out. So if we come over here, rotate. What we need is this guy here, so that we can extrude that ledge. Not this guy. We only need the interior. That's my fault. That exterior one is something else. So let's go ahead and take that depth measurement, which is looking to be 125. 1, 3. Let's do 1.3. So we're going to extrude that up 1.3. Mousey mouse. 1.3. So that becomes the interior bevel here. And then we have our 523. Let's get a better reading. I believe that's 5.2. 5.28. 5.3. So we're going to extrude this guy 5.3 plus 9.2, 5, 12, 12.5. Oh, come on. Strange. Very strange. Alright. It's not going to let us do that for some reason. It doesn't like that for some reason. Alright, we're going to turn this body off. It's strange. Extrude that down. 5.3. So 7, 8. 8 millimeters. Turn this body back on. What I want to do is merge these two. So go ahead and union nuts. The originals off. Bring that pocket back out. And now we have what looks pretty close to what we're going to get on the final. Hey, thanks. Yeah, I try to make them not boring, because I mean, really, it is boring without any other information. Just looking at some dude assembling lenses. Um, so hopefully, you guys get something useful out of this. So we're gonna move on to the flange area, like these little flanges here, and on the Sony. this marker is always going to point to the left if the camera is here, right? Your camera's here. It's always going to point to the left, and it is, I believe, 60 degrees, somewhere between 60 and 45 degrees in terms of rotation. Uh, what that means doesn't really matter. It matters more so in fine-tuning that final rotation of this, right? But since we have this as an indicator, again, what we're going to do is we're simply going to extend out on that end there, right? This edge here. So we're going to bring that and extend it out from rough center, and that looks rough center. All of this is so that we can get some rough idea of where 575 to get a rough idea of where we need to be in terms of how accurate we're going to be when printing that out so that we get proper alignment on the indicator up there. So, oops. Let's take that back. I want a line, and we're going to draw it out to the edge there, 27.5. Then call it that. I need a circle around that too. And again, we need to lock these down so they don't move when we make this new line. I'm going to change that to 575. See, now what happened is I didn't lock this radius down. So where is the circle? There it is. Let's lock that down. And we can come back here and we can change that to 575. And we can draw our line from there to there. And that gives us a starting point for the flanges. What we're going to do is we're going to measure roughly what this radius or what this diameter is. It's 46. Let's go back to our circles, add a circle and call it 46. That's our flange. So let's get rid of some lines here that we don't need, like these two. And then the funish part. Let's go back here. So what I learned from art and portrait drawing, right, is that everything relates to something. There's always there are points that you can reference off of on a model when you do the the finger thing, right, when you're measuring proportions, and that just applies to this stuff to design and I guess CAD work. There's always a point of a reference. So we've established the first point of reference, which is this guy here, the edge of this flange. And what we're going to do is we're going to use this to get measurements from here to here. Then we're going to measure from here to this point, from this point to this point to that point, and that point to that point. And then we're just going to keep measuring until our diagram or our CAD program looks or matches up with this here. So from that point that we measured initially to the point over there, get 20.8. Now you might have to do this multiple times. Might not have to. Everything might just end up working out for you. But I found that doing it multiple times makes it so it's easier in the long run so that your designs are much more accurate than. Is it 46 guy? That should be 46. There you go. Right, and then I just want to extend that out. That. Trim that, and then lock that down. Alright, what did I say here? I say this was 20.7, 20.8, 20.8. Then I want to draw another line there because that's going to be that, and then the distance from that endpoint to that point there. 24.6. I like 24.6. Hopefully it doesn't move. Perfect. It does not move. This guy, that guy. Get him 21.75. 75. Do that. And then what's next? This gap here. Thirty point nine, and then you can also see here that they always have a screw post here. And what we're going to do is we're simply going to measure the diameter of that screw head, and then make a block to fill that. 30.9. I promise we will get to the assembly. I know this is an assembly video, but I just wanted to show you guys how easy it is to get started doing this yourself. 17.9. 17.9. So if you are interested in the program that I'm using, Shapebird 3D, I swear to you, this is not a sales pitch, right? It's just me expressing relative satisfaction with what I've been using. It's Shapebird 3D, and they have a free version, 24.7. And lastly is just simply double checking what this distance is, which I'm totally off, right? It's this distance. Hey, that's pretty good, right? You see that? That final distance between those 2 points is roughly 21-ish, right? So what I have is 21.2175, which, for me is close enough. It's a good start. What we're going to do is we're going to print and refine, but I'll show that later. I'm going to print this while assembling, just to show you guys at the end. But if you do like the program, or if you think it looks interesting, Shapebird 3D offers a free version, which is pretty gimped, or pretty, I mean, it's functional, but it doesn't include a lot of the creature comforts that I would say that the full version has, which I mean, it's usually how it is, right? But let me see the thickness of this guy here. Let me use this. Let's do 1/6. That looks right. Yeah, that is what I'm getting here. 1/6. Let's extrude that down. 1.6. And then we need to locate where that stop pin is. So that is right side, which is over here. So let's go over here. Oh, right. Like I've been trying to say, Shaper 3D is subscription based. You can pay monthly or you can pay yearly. I pay yearly, so that's point two. So what we're gonna do here is draw a line that is perpendicular to this one here. Where's my perpendicular? There it is. I want that to be 1. And then we're going to draw another line here. That's going to be 1. And then we're simply going to connect those to the center. And then rotate and extrude it down so that alright, give me a new body. There you go. So that we get that that stop. Turn that off, turn that off, and we're going to move this guy negative 1.6. Then we're going to select that with that, and that, and that, and that, and we are going to combine those two, or those items. So, our rough lens mount, changing this Micro Four Thirds on the Samyang 12mm over to Sony E is almost done. What I like to do is I'll typically offset this center part here. 18 was my regular radius, so 36. What I will do now is simply select these guys. Oh man, should have trimmed those. And just inset that. I guess we could just use this as our gauge, like 4mm. Doesn't really matter. Just enough to give you the room to pass the contacts on the camera. So rough lens mount, that is it, right? We can also inset this area similar to this, right? We don't need a lot of this material, maybe just they take quite a bit of that out, and the radius 42, that's quite a bit, 42. Sure, let's do 42. See how that works. Two. Then we can take that and drop it like 4 or 5mm, just to give us. I mean, in the end, sure, you're still wasting material with support, but I mean, I think it's better than actually having to print that fully out. If you feel like you need that extra amount there, it's totally fine, but ish. We can also add a little bevel to this. Add a little bevel. Come on, guys. Come on. Add a little bevel here. Negative 0.5. It gives us a nice little bevel. But that is, generally speaking, how I go about it. What I also do is I also add a bevel here. Once you start printing, you'll run into something unavoidable that everybody runs into, and that's elephant's foot. So adding a bevel on the part where it's going to be facing the printer bed is it mitigates the effects of elephant's foot, but also I find it makes a much cleaner print. And for example, this came off the print bed, and you can see that bevel, and you can also see the wall is straight across the board. There's no bulge, right? So it doesn't go like that, which is what elephant's foot would do. Speaking of the 8mm Samyang, I have one of those, both the DSLR version and the APS-C mirrorless version. The tiny spring, yeah, you've got to be careful opening it up sometimes. I know on the, I haven't opened up the DSLR 8mm, but the mirrorless one, I don't think there's anything really important there. I've taken that mount off so many times to change it. I have an STL coming out for that one to replace the hood, so that you can use it on full frame. That's the reason I took the hood off of the 8mm mirrorless version. And then it has an attachable hood and also an attachable cover. But yeah, that's why I love 3D printing. It opens the world up for you to do really whatever you want with things that you buy, right? And if you want to change, a mount like this to another camera because either you're switching over or you bought one on a whim, it makes you have to spend less money. Like, yeah, sure, it takes a little time to learn, but the possibilities are absolutely endless. Right. So, let's turn that guy off. And what I want to do now is we will go ahead and export that. And so while 3MF is supposed to be the new 3D printing format, I still use STL because I haven't seen the benefits of 3MF yet. From what I understand, it's just a wrapper for an STL with additional metadata that you may or may not even use. So STL is still what I use. I usually do save each first level item separately, so what I get is a nice clean zip file, so that I always have a zip file instead of just having the loose STL files. We keep resolution on high, and then just export that. And you know what? I'll save it there. We'll call this. What is this? 12 mil. 12mm MFT2E. Call it a day. Yeah, see, it tells you that you should, but I don't. It doesn't really matter. 3MF, maybe. Like I said, if you like Shapered, if you like what you saw today with Shapered 3D, I mean, it's great for what it is, right? So recently what they've done is they've released it on Mac OS and Windows, originally being an iPad OS Yes, you still get vignetting without the hood, but so I do a lot of 360 panoramas, and I find that uh, my typical method is using an APS-C fisheye, uh, not fisheye, 180-degree fisheye, right? Not a full circular, but just 180-degree fisheye diagonal on full frame. It gives you a bigger image circle while cutting off a little bit, right? So um, on APS-C, this is the frame that you get, right? But on full frame, what you get is something like this. It's like a partially cropped circle. And what I find is that it gives you a better overall resolution when you stitch your panels or when you stitch your frames together, right? So um, it gives better resolution, and also it's cheaper than buying full frame circular fisheye um, lenses. So I mean, the cost to performance ratio didn't make sense for me to pick up like the Sigma 8 mm, or the Canon 8 to 16. Um, so that's the purpose of that. That's the entire purpose of removing the hood and replacing it with something that you can remove on and off. Is simply that for you know the Google tours and virtual tours, better resolution, better overall image, um, with using an APS-C lens, um, 8 mm APS-C lens on full frame. So yeah, back to the Shapered, right? It's uh, right now it's $20 a month or 240 a month a year. Let's see, $30 a month, right? Uh, $20 a month if you do it yearly. I think it's totally worth it. I mean, if you look at a lot of the CAD programs out there, it's like thousands of dollars for a license. The cross-platform compatibility, right? So if I turn on Sync with Shaper 3D, everything that I do on my iPad, it gets uploaded to the cloud. I don't particularly know what the privacy policy is or the ownership policy is there. Um, I'll have to look into that. But if I turn on Sync, whatever I do on my iPad is synced to my Windows PC, and I can just work from there. But yeah, again, totally not a sales thing, right? Not a sales pitch. I love how easy it is to use. Um, yeah, next week we'll be using, or I'm sorry, this Friday we'll go through some FreeCAD stuff uh, for that. The last thing I do want to do, if I can pull this up, is yeah, the 12 mm. I think it's 12 mm is 180 degrees fisheye, right? I think with that one you'll get a better, more photos, better resolution than with the four frames on the 8 mm. Um, I like to what I had to offer clients is timeliness and resolution and overall quality. I found the 8 mm works fine. There's this dude on YouTube. I'm sorry, give me a sec. There's this guy on YouTube who does a lot of VR and 360 reviews. He does great stuff. He generally suggests, I think it's the new 11 or 8 mm TT Artisan lens for APS-C on full frame uh, to do panos, the four-shot panos. Yeah, So the last thing I'll do um, is let's go ahead and I'm going to show you my general settings on Cura, what I typically use to print everything, to make sure everything is as dimensionally accurate as I can get um, printing. It takes a little while to tune your 3D printer once you do get it and once you start understanding how to use it. Um, but generally speaking, I do 6 walls over the standard, like 3 or 4, because I need durability. The strength of your print is heavily reliant on the number of walls you print versus the infill that you have. It may be different if you're printing a solid thing, right? A solid 100% infill, like 8,000 walls, right? But generally speaking, if you're printing infill and you want the strongest print, more walls will equal a stronger print, right? So what more walls and more top and bottom. Uh, do initial layer expansion to help combat elephant's footing, and then the overall flow is determined by your printer. So you've got to do your E-steps, you've got to do your flow calibrations, um, and then you've got to fine tune it by doing. So there's a shrinkage test you can do. PETG has like I want to say like a 1%, 0.5 to 1% shrinkage rate. So what that means is in Cura, what you're going to have to do to compensate for that typically is go to your scaling and add a 0.5 or something like that. But that's scaling should only be done uh, if when you print the file and it doesn't end up being accurate, what you can do is you can take the measurement of the print, and then let's say like it's off, right? Like this is supposed to be yeah, so 60. Uh, that's 60.3, right? So it's supposed to be 60. What you can do is you can take that number, divide it by what it's supposed to be, you'll get a percentage, right? And then you can input that percentage into Cura to scale it. Always continuing to improve stuff. But I'll try to show you guys FreeCAD on Friday. And with that, because we're done here, you can go back and it'll save everything automatically. It doesn't have some of the creature comforts that, what do you call, that like SolidWorks has, like gear generation, stuff like that. Um, it doesn't have, uh, it doesn't have the animation tools in that it doesn't allow you to um, animate things so that you see how they run. So if we're talking about gears, it won't show you. You don't have the ability to see how the gears mesh with each other before printing it. Um, but I think workarounds with that is probably importing the files into Blender and then running an animation there to see if it works correctly. I'm sorry, I'm setting up the assembly part right now, and I am running around with the Game Boy. Uh, but yeah, it doesn't have a lot of those creature comforts. I don't think FreeCAD has it either. Uh, there we go. And all right. going to scale that a little bit and then pop in. Oh no, you guys are sitting behind the scenes stuff. Every time I unplug things and don't have them plugged in correctly, they tend to go back to their old settings. So we're going to go like that. There we go. There we go, guys. Enough of that. Let's put that there. That's too big. That's too big. All right. Let's jump back into the assembly. Oh yeah, if you wanted to check out all of the stuff that I do for the virtual tour stuff, all this is done on 8mm 4 shots full frame. Yeah, enough. Like again, cost to performance ratio and what I can offer clients in terms of brevity in me being on their site versus having to take as many as like 12 or more photos on something that gives me a wider or a smaller field of view is what I'm generally after. The 8mm offers that. Alright, so I'm going to assemble this guy and then we'll get the assembly for the other stuff going. Drop that in there. There. And what's great about these Samyang lenses is that they do have those shims there. So I mean, if you're missing critical focus, you can always go in and just adjust it there by removing a few if you don't need them. All right, close that guy up. Unplug that, turn that off. Oh wow. Okay, assembly today is going to include a bunch of cleanup. Maybe not. No, no cleanup. So we're going to assemble this half, and then we'll probably start assembling the lens mount portion. All right. Do fitment tests. So, going back to the woodworking stuff from last time, one of the few things that I have left from it is this guy here. Um, and it was always a big thing for me to find a way to use scraps because woodworking and design in general is very generative of waste, right? We've got a lot of cutoffs that are too small to be used for anything. So what I did was I found a essentially like a bead drill, right? So you drill one side, you get a half dome, and then you run it through the other side, you get the full bead. Um, so that's what I would do with the scraps. This is actually made up of four different woods. My favorite Padauk here, it turns this really dark red, maybe even black, but when it's raw, it's orangey, orange red. African mahogany. This guy, it's probably teak. The order is wrong on here. Um, but it was mahogany, walnut, and then I used to work at a winery doing graphic design, and I picked up a couple of barrels, and I used the barrel staves as uh, material for the beads too. There's a clicking that I'm trying to locate. I don't like that clicking because it sounds like it's going to interfere uh, with the overall function when you focus. I can't pinpoint it, and I know I'm wearing headphones, but I can feel and I can kind of hear it somewhere in the back here. So I changed the orientation, and that did not help. It's actually probably worse now. So there's a. Oh man, I had my hands on the new iPhone 14, and honestly, I'm a little disappointed with the new design. It's very dense. Uh, like it feels like a brick, very dense. A little disappointed, but it's I'm still on an iPhone 8. And I don't think I'll be upgrading anytime soon. I like the Touch ID, that little button circle. There we go. I like that. So adjust this a little bit. The LCD driver is coming soon. Right now it's over at Customs. Um, Probably another day or two before it's actually shipped out from Customs in New Jersey. Um, I don't know why I got it. I don't know if I'm even going to use it as an LCD, the iMac. But I mean, worst comes to worst, I'll make yeah, I'll just use it as a second screen. I do want to keep it though. It's got sentimental value. Is that what they call it? Yeah, sentimental value. So yeah, I think the iPhone X is still like I think literally anything from iPhone 10 up is until the current version is still fine. I'm feeling a little sluggish on the iPhone 8, and the battery life's not too good. But you know, I've got no real reason to upgrade. Um, Camera wise, I am pretty impressed with the iPhone 14. I've been impressed with the iPhone cameras for probably since like the 11 or 12. Got fantastic cameras, but I mean, like, you know, I use mirrorless cameras for most everything that I do. So I'm not, again, I'm not overly eager to upgrade at this point. Oh, dude, I appreciate it. Yeah, I'm working as fast as I can to get these out, and I know if it were me waiting for it, I'd be impatient, and I hate knowing that in the back of my head, um, there are people who are like, F this guy being so slow, right? Because I mean, in my head, that's probably what I'd be doing to myself. I am working as fast as I can to get these out to you. I've got I've got a shipment going this week, maybe 20, um, maybe 30 if I can finish this batch by the weekend. Um, Typically ship on Fridays if people don't reply by Friday. Um, they'll be in the next one, or if they do reply on Friday, I'll ship it out on Saturday. Huh. Oh, something wrong with this one. There's a bump somewhere in here. I think there it is. Yeah, yeah, right there. So, I guess while I'm doing this, I can talk about materials since there was interest expressed in material selection. So, with 3D printing, there's quite a bit of you get a quite a fair bit of choices with filament type and material type, same thing. Um, and typically on a scale of what's easiest to print and what's hardest to print, PLA is easiest. I think PETG and ABS are somewhere in the middle. Um, and then, ASA, which I think it's close to the same properties as ABS, maybe a little bit better. It's kind of harder. And then, your nylons and your TPUs are typically harder to print when starting out because nylon requires an enclosed chamber and like a stable heat, and it also requires you to have it thoroughly dried, just like PETG and most other filaments. But it's just that PETG and nylon are pretty hygroscopic, so they'll absorb a lot of water, or they'll absorb as much of the humidity around you and become brittle. And it's only an important factor when printing. After printing, it doesn't matter so much because you're not printing with it. It's in its final form, so it'll reach its, I guess, relative equilibrium with its water content. Thanks. I appreciate it. It makes me a little less worried, one less thing to beat myself up over. Yeah, material selection. Uh, People always say start with PETG, but I actually never printed PETG. I've never, or start with PLA. I never print with PLA. I just think it's way too, I guess, fragile uh, to invest that much in printing something that will melt or deform in the heat. PETG just, I mean, it's almost as easy as PLA to print, um, without the drawback of deforming in heat, which I mean, I I don't like I don't like what's that word? I don't like having to be so careful with my things, right? I'm typically rough with whatever I have. Hey, no worries. Your typing's fine. I appreciate you keeping me company. I'm slowly losing my mind doing all this. Maybe by the end of this, I'll be a shell of who I was. Yeah, I'm typically rough with my prints, and this is a 3D printed case. This is Tulum Alloy 310, which is it's a nylon. It's kind of a nylon. I guess its base is nylon, um, but its impact resistance is much higher than PETG, which is why I made a phone case out of it. I was trying out a few different materials, and while PETG prints fine, impact resistance is very poor. I can't drop. If I were to drop this and it was PETG, it would literally just like explode. But this alloy 310 it's got good impact resistance with heat resistance. Um, but yeah, PETG just makes more sense for everyday printing. You can throw things in the sun, you can throw things in your car without having to worry as much with uh, without having to worry as much things deforming like you would with PLA. Um, I think I think PETG should be like default for anybody starting because it's a great it's a great material, um, and it's a hardy material, I guess. I'll be right back. I've got to check something. All right, take it easy. Thanks for stopping by, keeping me company. That's good. So unrelated to 3D printing, um, I remember when John Newman came out. He's a British artist. I uh, I loved his stuff, and then like he just kind of disappeared for a while. I was really disappointed. I only recently found out. I think he had like a brain tumor, which I totally understand why he had to stop making music. But it's fantastic discography. Um, I think his work with Calvin Harris was good too. But I mean, I've got to find out if he released any vinyls so I can pick it up. Oh, yeah. I mean, I should probably be listening to it right now. Boom. All right. What is next? That's next. Uh, my body. I'm looking after what I was looking for. All right. I'm gonna pair them off. It's a little tight. Why is it a little tight? Okay. Then I need clutches, aperture clutches. I should probably print. I don't like that. I don't like that at all. Probably print a few more of these on my to print list. right, I think we're alone again. Why doesn't that look right? Okay. Clean these guys up, install them with grease, drill the holes, tap the holes, drill the holes, tap the holes. That should take us to 8. Alright, let's clean this up. Straight edge. So, I've been looking for ways to speed up um, resin cleanup, I guess. Um, Let me show you what I'm talking about. So this is the focus track, and this is how they come off of the resin printer. Um, they there's a lot of supports here, and cleaning up by hand it's a chore, like an absolute chore. So I've been looking for ways to increase the or to decrease the amount of time it takes to clean this up. And I think I found an effective way is that once this is all clear through the UV and all the resin has been cleaned off, all the alcohol has been cleaned off. Yeah, I let them sit for a few days to further, I guess, harden, cure, whatever you want to call it, whatever, just dry off. Then I take this flesh cut saw, flesh cut draw saw, a Japanese style, um, and I cut the base off. And once I cut the base off, everything kind of just falls apart, right? Everything just kind of comes off, which, while it may not seem like it takes too long to do any of this, like I've got to do this for like 200 of them, right? And any time that I can save in cleanup is time I can use towards assembling lenses, shipping lenses, uh, stuff like that. Perfect. Oh, because it's October, uh, I started October watching Hocus Pocus. Not Hocus Pocus 2, but Hocus Pocus, the original, 1993 version. Uh, like, I think it still holds up. It's still pretty good. Uh, I've read reviews on Hocus Pocus 2, which is kind of why I'm not watching it. It seems like another nostalgia cash grab. And I think headcanon, Hocus Pocus 1 is Hocus Pocus 1 is probably all we needed. Uh, I'm curious to know why they didn't cast uh, the original family in there, right? Doesn't make sense. But uh, they seemed happy with the final product, so I think that's all that really matters. Um, if the creators were happy, then you can't really say much.